Good morning. This is your stats sensei, Mr. Spensei, and I'm going to break down our pre-quiz. Real estate advertisement provides the following information about houses in the Stone Oak area with regards to a two-car garage and 5 bedrooms. Use the Venn diagram below to answer the following questions. What is the probability that a house has a two-car garage? Well, this circle right here includes two-car garage. So in this case, we have 0.72 plus 0.09 equals 0.81. So there's an 81% chance that a house has a two-car garage. What's the probability that a house does not have 5 bedrooms? Well, the easiest way is to figure out what's the probability it does have 5 bedrooms. Well, if I look at that, that's 0.07 plus 0.09. That has 5 bedrooms, but we want does not. So we want the complement, which is 1 minus. So when we do that, we end up getting 0.84. What's the probability that a house does not have either? So in other words, I'm looking for, if I were to put a box around this, I'm looking for the area that's not in the circles, that's in the box. So the easiest way to go about that would be 1 minus the bracket 0.07 plus 0.09 plus 0.72. And since I'm not trusting my math this morning, I'm going to go ahead and break out my calculator. And that looks pretty good. Shows up pretty well. So 1 minus, and then parenthesis 0.07 plus 0.09 plus 0.72 and close the parenthesis. And I get 12%. So 12% would be what's outside of the box, and that would be my answer to that particular problem. In a certain school, 19% of the students are enrolled in psychology course, 33% are enrolled in the statistics course, and 50% are not enrolled in either. All right. Complete the Venn diagram. Be certain to include the percent of people who are enrolled in both courses. All right. So 50% are not enrolled in either. That means this area out here is 0.58. All right, so that area out there is 0.58. And I'm going to go ahead and put PSY for psych, and this is stat. All right, I can't just label them directly. Now, I'm going to use the general addition rule. This is going to be the probability of psych union the probability of stats equals the probability of psych plus the probability of stats minus the probability of psych and stats. And I got to be careful. I mean, I got to be honest with you. This is kind of a tricky problem. So, what do we know? 19% are in psych. Okay. And 33% are in stat. But now I don't have this or that. But if this is 58%, this is going to be the complement. So this means the area. So the area out in the box is 58%. So this is going to be 1 minus 0.58 equals 0.42. And that's the area in the circle. So this is going to be 0.42. And at that point, it's like, oh, all I'm missing is this at the end. So I can go ahead and solve for that. So with that said, 0.19 plus 0.33 is 0.52. So 0.42 equals 0.52 minus x. And when I solve, I end up getting 0.10 equals x. So this right here is 10%. All right. Well, now that I know that this is 10%, well, what did they say psych was? 19% is supposed to be psych. That means this has to be 19 minus 0.10, which is 0.09. And the stat was supposed to be 33%, so this is 0.33 minus 0.10, and that should equal 0.23. So let's check this out real quickly. First off, 0.09 plus 0.10 plus 0.23. All right, that's 0.42. And then so that means this area right here is 0.42, and that's what we said just a moment ago. And then if I add the 0.42 plus the 0.58, I end up getting one whole, and that makes sense because this whole thing needs to add up to be a valid probability distribution. All right, that's a bit tricky of a problem. If probability of A equals 0.47 and the probability of the intersection equals 0.13 and the probability of A union B is 0.82, then what's the probability of B? Well, once again, they want us to use the general addition rule. And the general addition rule is simply probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. All right, so the probability of A is 0.47. The probability of B, we don't know, so I'm just going to write B. But we know the intersection. They told us that is 0.13. And they told us A union B is 0.81. So I'm going to combine the 0.47 and the 0.13. So 0.47 minus 0.13, because I said minus, equals, oops, it would help if I use the decimal, 0.47 minus 0.13, and that gives me 0.34. So now I have 0.81 equals 0.34 plus B. So this is a B. And I'm going to, because that's that B right there, and I'm going to go ahead and subtract that from both sides. So 0.81 minus 0.34 equals 0.47. All right. Now, it turns out A and B happen to be the same thing. So let's check it out real quickly. 0.47 plus 0.47 minus 0.13. 0.47 plus 0.47 minus 0.13. All right, that's 0.81, and that was 0.81, so we must have done it correctly. All right, moving on to the next problem. All right, it says the situation below is a spinner, blah, blah, blah. What's the probability does not win anything? Okay, so does not win anything means we want the probability that they get zero. Well, how many zeros? Well, first off, how many are on the wheel? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 spaces on the wheel. And it says, what's the probability does not win anything? Well, that's a probability of zero. And we have 1, 2, 3, 4, 5, 6. All right. So 6 spaces out of 10. So the probability of getting zero equals 6 out of 10, which is 0.6 or 0.60. What is the probability that receives less than $10? Well, there's 110 on there, and everything else, if I count it up, there's 11. So the probability of less than 10 equals 9 out of 10, which is 0.10. What's the probability 4 consecutive winners win at least $1? All right. So in this case, that would be 1, 2, 3, and 4. We're looking for the probability that X is greater than or equal to 1. So that means there's 4, and it says, well, let me check that again. 1, 2, 3, 4. And it says probability 4. All right, so that means I need 4 spaces. This is 4/10 and 4/10 and 4/10 and 4/10. Now I need to multiply all of these. So 4 divided by 10 raised to the 4th power. I get 0.0256. And by the way, I do want the decimal answer. All right. So that's that problem. What's the probability that 5 customers in a row win nothing? So we want the probability of 0, but we need it 5 times in a row. 1, 2, 3, 4, 5. We said earlier the probability of getting 0 was 6 out of 10. So 6 tenths times 6 tenths. So in this case, 6 divided by 10 is 0.6. Then I'm going to raise that to the 5th power, 0.0776. And by the way, we want at least 4 decimal places written down. So 0.0776. I wrote down 5 just because it's more complete, but that's 4 is fine. What's the probability the first dollar winner occurs on the 5th spin? All right, so here's the problem. We need not $1, not $1, not $1, not $1, $1. So this has to be a $1 winner. This is not a 1. This is not 1, not 1, and not 1. So let's focus on the $1 winners first. All right. How many $1 winners are there? Well, we have 1, 2, 3 out of 10 spaces. So this is 3 out of 10. All right. So this is going to be 3 out of 10. And it's like, oh, well, that means 7 of them aren't $1 winners. And let's check that out. So 1, 2, 3, 4, 5, 6, 7. So 7 out of 10 times 7 out of 10. And there's a couple ways to mathematically do this. I'm going to show you what I'm going to do. So I have 7 tenths. 7 divided by 10. But I needed 1, 2, 3, 4 of those. So I'm just going to raise that to the 4th power. And then I'm going to multiply that times 3 tenths. So times 3 divided by 10. And I get 0.07203. All right, the next problem. All right, the next problem says, what is the expected calculator sold? And they give us these values. Well, probability, that's another word for frequency, is how often do we expect it to happen, the percent of the time. In this case, I'm going to go into stat edit, and I'm going to go ahead and clear this stuff out. And it turns out that we had, let's see if I can get that all on the screen. There we go. That's pretty good. 2,000, 5,000, 10,000, and 20,000. And this is 0.1, 0.3, 0.4, 0.2. So stat calc, one variable stat. And I end up getting X is 9,700. Well, you know what? I should do that real, be careful. My X list is L1 because that's the number sold. And then my frequency is always my probability. So wherever your frequency list will always be the probability. So that's L2. All right, so 9,700. So the expected value, and I'm just going to write down X bar just so that you know is 9,700. All right, well, they're going to ask us to do the same thing here, but we're missing a number. Well, I need to add up all these numbers. When I add them all up, they have to equal 1. So let's do this. And we have 0.35 plus 0.25 plus 0.15. Well, that's that. And oh, excuse me, and I left off a number. So 0.35 plus 0.25 plus 0.15 plus 0.05. And then 1 minus that tells me that this value needs to be 0.2. All right. So now that I have that, remember probability is frequency. And I'm going to put this into the calculator. So I'm going to go stat edit. I'm going to clear that out. I'm going to clear that out. and I have 0, enter, 1, enter, 2, enter, oops, 3, enter, and then I'm going to enter 4 as well. And then I'm going to go over and put 0.35, 0.25, 0.15, 0.05, and then the one I calculated was 0.2. I'm going to go stat, calc, one variable statistics. List is L1, frequency, that's my probability, is L2. Sorry about that. And then I end up with an X bar of 1.5 equals X bar equals 1.5. Then it also asks for the standard deviation, which will be this symbol. And in this particular case, just weirdly, it just happened that this also equals 1.5. All right, so that takes care of 13 and 14. All right, the next one. What is the probability that a randomly selected woman has a positive mammogram? Well, it's like, okay, 0.0691. Actually, 0.0691 over 1, but just 0.0691 because that's the probability of positive. What's the probability a randomly selected woman tests positive and does have cancer? Remember, and is the intersection symbol. It also means the probability of both. All right. So positive and cancer, that's right there. So that's 0.0097 because they positive and cancer intersect right there. Next one says, given the test is positive. Oh, so now we are given something. So we're given positive. And remember, anytime it's given, it's intersection over given, which in this case, given that it's positive, so positive is in the denominator, and the probability of positive is 0.0691. And we want it to intersect with has cancer. So intersect with cancer is 0.0097. And I would like to see the fraction, and I also want to see 0.0097 divided by 0.0691. And that's 0.1403. I always like to truncate, but if you round it, that's fine, but 0.1403. All right, that takes care of that. Now for the table. Suppose 4% of the population have a disease. All right, well, that 4% is associated with having the disease, so that's associated with one variable. A laboratory blood test gives a positive reading for 95%, so this has a positive reading for 95% who have the disease. Ooh, that's associated with test results and with the disease. And it also tests positive for 5% who do not have the disease. So once again, positive, this is positive and disease, so this is also two variables. We always want to find the one that associated with one. So once we find that, we can write it right down here. So this is 0.04. This makes this 0.96. Once I do that, I'm just going to bring these values up. This is 0.04. This is 0.04. And by the way, this came from 1 minus 0.04. And I'm going to put those in parentheses. I'm going to put those in parentheses. And I'm going to have to put some labels on here in just a second. And 0.96. Now, I keep my labels really, really simple. This 4% have the disease. All right, that's disease. Then this would be not have the disease. That works pretty well. The other thing was test results being positive or negative. So plus sign for positive, minus sign for negative, just keeping it simple. A laboratory gives a positive reading for 95% who have the disease. So it's positive for 95% that have the disease. Well, positive disease is right here. So this is 0.95. Well, wherever I place this value, The other place in that column has to be 1 minus. So this is 1 minus 0.95. So in this case, 0.04 times 0.95 is 0.038. And that's the value I'm most interested in, is the 0.038. And then 0.04 times parenthesis 1 minus 0.95 is 0.002. Now, if I add up these two values, this plus this, it has to equal 0.04. And in this case, it does. That does not look like a 2, but that's supposed to be a 2. All right, we have one more value. And it says, and it also tests positive for 5% who do not have the disease. So that means this right here is going to be 0.05. And this is going to be 1 minus 0.05. So 0.96 times 0.05 is 0.048. And then 0.96 times 0.95 is 0.912. Now, once again, this plus this equals that. So I probably am doing things right. Now I need to get these values. Well, if I put a plus sign here and an equal sign there, this plus this, so 0.038, let me clear that out, 0.038, which came from right here, plus 0.048, equals 0.086. And then the next one, 0.002, 0.002 plus 0.912 equals 0.914. Let's check this out. Let's add the 0.086 to it, and we get 1 whole. All right. Thanks for watching. That's the pre-quiz. I hope that helped.